Well, welcome out to DockerCon and the Using Docker track. I want to introduce Brett Fisher. Brett's been working hard for over 25 years, done all kinds of stuff, whether it be in the U.S. Navy, a developer, sysadmin, and many of you might recognize his pretty face from Udemy and the Mastering Docker series. So I'm going to give it up for Brett, and he's going to present on building your Docker tech stack.
Thank you. Thank you, Robert. Okay, so we have a lot to go through, so I'm going to get started, even though we got people still filtering in. The URL here is going to have everything you need. There's going to be a lot of demo here. We're going to have lots of config files, lots of resources, and I've got probably 30 or 40 links all in that URL. I'll put it again at the end of the slides. So also later today, I will put up a PDF of the slides, and that way you don't have to take pictures if you don't want to, unless you want to tweet about them. And also, I'm on Twitter, like everybody else here, so that's the thing. So the way this talk started was last year. If you got to see my sessions last year, we basically talked about basic decisions around going in production. So that gave you like OS decisions, image decisions, stuff like that. And what came out of that was a lot of people talking about, well, if I'm going to build a cluster, what are the other things I need? I need more than just a Docker engine and an orchestrator, and that's true. There's lots of other components and pieces to that puzzle. So that's what this talk is really about. And if you remember a while back, I mean, this is still a thing, but 15, 20 years ago when life was simpler on the internet, we could do simple things like have a LAMP stack. And the LAMP stack with Linux, Apache, MySQL, and PHP, right? We don't really have that for containers yet, right? There's so many choices out there that it's tough to make a decision around all the different layers of your stack. And I'm going to make a timer here. World's most expensive T-steeper. Anyway, timing. So we're going to have cloud-native container tools here, and the challenge is that all this stuff is new, right? Or at least most of it. And so it's hard to know what's new and what's really valuable and what's not, and what's maybe not working yet or does kind of work and what does actually work. So let's go through some of that stuff. And we need some more patterns and examples. So I'm not saying my patterns and examples are the right ones for you. I'm saying these are examples of ways you might build it out. Obviously, there's lots of choice, and you're going to need to make your own decisions. Maybe you choose more commercial and less open source, or vice versa. I'm just going to give you some stuff that I know works and works for some people, not necessarily for everyone, right? So 4 goals for today is to build out some full-ish stacks of container orchestration. And this is going to start with the solo DevOps, solo sysadmin, and then work its way up to a team level where you've got multiple DevOps operators that are managing a cluster. And you have to make those kinds of decisions around permissions and sharing of everything and reproducing everything. Because a lot of us, I think, in a lot of situations, end up being stuck with that sysadmin problem of you have to do this yourself. And you don't necessarily need the full-on high-end solution that a team of 20 needs to have, right? So it's OK to make simpler tools for smaller teams or single solo people. And also a goal is always to, if you want to avoid cloud lock-in, we're going to try to do that. So any layer of the stack, we can be able to swap that out for something else without a huge amount of disruption. And if you weren't here last time, my talk last year, just a real quick recap that's in the slide link. It's a great resource to use as a precursor to this talk around going production, making decisions. Projects need to be as small as possible. That's a project killer, is people adding every possible feature they want to the project timeline. That just kills projects and containers. You want to limit the new as much as possible. Focus on the quality of your Docker files. Use a 4.x kernel on Linux. Obviously, if you're on Windows, the choice is easy. You get one choice and it works. But if you're on Linux, you've got lots of choice. But at least make one that is a 4.x kernel. They don't all still. Some of them still actually ship with 3.something kernels, which are over 5 years old now. So you don't want to do that. Base images, keep them familiar to your team. Whatever you're used to now in non-container land, just do that in containers. If it's Ubuntu, CentOS, whatever you're using today, keep doing that in containers. Avoid changing the entire stack just because you want to use something cool like Alpine. Do that for something later. And then if you didn't know, Swarm, which is a large part of this topic today, I'm a big fan of Swarm, is you can use it on one node. So in any situation where you have a server that you want to deploy containers, consider Swarm as the solution rather than just a plain Docker engine. Swarm has so much more out of the box, and it works great on one node. Obviously, it's not highly available, but we have situations where we need to just run something in a container on one server. So try out Swarm at one node. And then Swarm EE is, as you will see through this talk, a sort of an easy button for a lot of these problems because it comes opinionated out of the box. So we're going to be building 2 stacks here, Docker CE, which has benefits and pros and cons, right? This is all pros and cons. And then Docker EE, and seeing how the two compare. What if I have to build out if I choose one of these 2 options? And just a reminder that clusters are complex, right? And you need to build this over time. I have some resources about how you evolve that. There's some links online to some other great talks by some people that are probably in the room, by Jeremiah. And this basically is all about how your day one cluster should not be the ultimate cluster. It should be the smallest, simplest cluster. And then you evolve it over time. This stuff is all meant to be replaceable and dynamic. So you shouldn't wait to go production until you have a fleet of 100 servers on day one, right? Start small, start simple. All right, so you've probably seen this slide. This is sort of like the marketing slide of what the features are of EE or the different parts of that stuff. But you may not realize that in the open source CE, which probably a lot of us are using, you don't get all that, right? You have a couple of features out of the box, but you're missing a lot of the pieces of that puzzle. So we're going to look at how to fill that out. But like every talk I usually do, because I'm a nerd, and I've been around a long time, I reference old stuff, and this is all for fun anyway, right? If we're not having fun, why are you here? So we're going to talk a little bit about, just for a second, that sci-fi is great. In fact, this year, I feel like we're in the golden age of television, but we're in the golden age of sci-fi. Like, this is just 2018 TV and movies. Most of these I've seen or want to see, and we're killing it, right? Great stuff. So one of the cool things about sci-fi is the soundtrack, right? And of course, sound in presentations is always fun. And if you saw my talk last time, I did 8-bit video game trivia. But this time, we're going to do some sci-fi stuff. So for this application that we're going to deploy, we're going to imagine ourselves as a business. And that business is ultimately going to be
dog versus cat.
So dog versus cat, you've probably seen the vote demo. Why not have sound effects? And we're going to play around with some of the tools and see how we can build them up in Swarm as a live demo. So any particular company doesn't have just one app, right? If you're going to have a minimum Swarm, you're probably going to have some basic apps. So what we're going to do is we're going to deploy 3 different apps. Basically, one's a static website. One is the voting app. If you've ever seen that sample app from Docker, it's a distributed service with persistent storage. And then we're also going to do a ghost blog because you got to blog about your voting of dogs versus cats, right? But these are all going to be in their own stack files. And in fact,
laugh it up, fuzzball.
We're going to build it like Han Solo sysadmin first, right? So how many people in the room, you are basically the solo DevOps person? How many people here? All right, so 25%, 20%. So there's a lot of us like that. Even if it's just your hobby project, you now are elected as the DevOps person where you have to build out servers. So basically, if you were running this little startup business, right, dog versus .cat, because that's the cool trendy thing is to get these new domains, and you've got a bunch of requirements that you have, and notice that you have optional requirements that are probably cool things you should do someday, but they maybe aren't what you need day one. Again, starting simple, learning the lessons, and then growing as complexity grows, layering those tools on top. This actually works really well, starting with these simple concepts and then working up to the complicated ones on the right. Okay? So this is a typical question I get in my courses, in my workshops. A lot of students will ask me, but how can I deploy a multi-tier app in a simple orchestration way that gives me auto recovery and simple load balancing out of the box without a whole lot of work, right? I don't want to spend 100 hours a project just to do something basic. That's the dream of containers, is that we don't have to have complicated infrastructure in order to have simple concepts like load balancing. Notice that I didn't say high availability. I just said auto recovery. Because in the smallest sense, if you're a small team and you can suffer a minute outage on the internet because you're not a business of that level yet, or that the thing that you need to do today is not something that requires that level, then maybe you don't actually need redundancy. You just need an orchestrator to automatically recover from a failure of a container, of a failure of a node. Turns out that that's actually 2 different choices: high availability, auto recovery. So maybe they only need that, right? Maybe Han Solo only needs that. So the first one we're going to do is DigitalOcean, because that's an easy demo place, right? And you can scale 10, 20 servers very easily there. Obviously, it doesn't have all of the networking advancements and all the fancy stuff of AWS, but maybe, in your case, a simple 3-server swarm is all you need. So we're going to use a couple of resources out of DigitalOcean. We're going to create 3 droplets. We're going to use their persistent storage engine, block storage, because we have databases that we have to care about. And then we're going to use a load balancer in front of our swarm for multi-node high availability. And again, if you saw this slide earlier, we realized that as an operator, you have more infrastructure that actually relates to this app. So as you bring this app larger scale, you realize, OK, I need something in front of it. And we're going to use traffic, an open source reverse proxy, which will allow you to run multiple websites on the same port. So you're going to need that in most orchestration in order to run a bunch of websites, right? And then you're probably going to need to isolate these things. So we're going to use overlay networks to isolate the traffic so that our databases don't have the ability to see each other, and if something gets exposed, something else doesn't get automatically hacked. So that's built out of the box with Swarm, right? And then you're going to need other tools along with that, right? So you're going to need centralized logging and centralized monitoring and maybe a GUI that manages your Swarm. Maybe you're going to need alerting and stuff like that. You're going to need persistent storage. So we'll have all that stuff. And then finally, you're going to have multiple nodes. So all this stuff has to be able to move back and forth between nodes seamlessly. Swarm does that pretty well with the overlay networking. But we have other considerations here. So we technically have 2 layers of load balancing. That top layer is DigitalOcean, and the middle layer is traffic running as its own container service in Swarm. So let's actually get to it. The stack is going to look like this. This is the first demo. And we're going to start with Docker Machine. Most people would not recommend you build a server cluster in production with Docker Machine. But I'm going to argue that if you're a solo DevOps person, you don't have any, all you need to worry about is backing up your source files and your keys. You don't necessarily have to worry about sharing this thing around with 20 people on the team that all have to use it to manage servers, right? So Docker Machine is pretty good at that. It stores certificates locally. It puts them in your profile as long as you're backing that up. It works pretty well for 5 to 20 servers. Once you get to that point, it hits its limits and it becomes sort of slow to use. And you want to use a better tool like Ansible. So you work your way up the stack. You have a bunch of projects there. We'll get into those in a second. So let's jump in. Basically, right before this talk, all I did was create some instances with Docker Machine because you probably didn't want to watch me do that. And yeah, so what we have here is hopefully I didn't even check to see if they were working. Hopefully they're working. Let's find out. Docker Machine. Right, so I got 3 servers. And there we go, see? Didn't check. Maybe the internet. Thinking. All right, so we're going to do some live troubleshooting right off the bat. This is the fun part, right? So cool. All right, no worries. So all I did was I was going to show you the script while we looked at this. But it's just basically a bash script down here at the bottom that just does a Docker machine, and it creates a server, right? So we're just going to create a server, and then we'll come back to it. Oh, that's not the wrong one. That's the wrong one. This one. Sorry. So if you didn't know, you can use Docker Machine to create servers on the internet. You can create them on your local machine, whether it's Hyper-V, VirtualBox, VMware. All those things are drivers inside of Docker Machine. And all Docker Machine does is provision an instance, install Docker for you. So it works great, and it's nice because it manages the TLS connection to Docker, so you have a nice secure connection remotely, and you don't have to SSH in the box. So I'm going to just make this one. Okay. Okay. Try that again. All right, so hopefully this one will finish. And while we're doing that, I will talk about we'll actually look at the scripts real quick. So these are all pretty simple. All right, I showed you this one. By the way, this is all part of a repo. In the links list, you'll see a repo with all the resources of these files and stuff. So we're just creating a couple of servers here, and then we're going to do the Docker swarm init, which everybody's probably typed that command or seen that demo where you just create a swarm with one command, and then you add each node to the swarm with another command. A whole lot of magic that happens in the background. Well, not magic, but it seems magical because it's way easy to do. But we're just going to run this real quick and get a key, make a 3-node swarm, and in fact, we can, while we're waiting on that one, we can actually skip ahead. So instead of me typing all these out, actually, before we do that, let's do enable monitoring. So the other thing you want to do is if you're going to use Prometheus or any sort of monitoring tool, you're going to want to enable the monitoring endpoint. Now I hear a rumor that we're close to the monitoring built into the engine actually coming out of experimental. But right now what you have to do is you have to actually update your daemon in Docker to get this monitoring endpoint. And it's pretty great. It spits out Prometheus style monitoring metrics. And we want that in most cases, especially if you're going to use something that can read it, right? Like Prometheus. Now Datadog reads Prometheus. That's becoming a standard, and other tools are all sort of accepting that thing. But you just need to do a simple daemon update on the JSON file. If you've ever had to manage Docker servers, you probably have had to manage the daemon file and put specific settings in there. And we're installing Docker. And then once you've got those three, basically, we would have a 3-node swarm, right? We'd have 3 servers. They're connected together. They're on overlay networks together. I already created the load balancer because that's a boring thing you do in the interface of DigitalOcean, so we don't need to actually do that. And as soon as this finishes, we'll do those commands. All right, I'm going to skip ahead a couple slides. So next thing up is RexRay. RexRay is a storage plugin that basically orchestrates your storage. And one of the problems with storage and orchestration is that it needs to be on the right node at the right time. When you run a container that needs a database and it needs a persistent off-disk storage, off-the-server storage, it needs to be orchestrated so that that connection is on the right node wherever that container is running. And if that container has to move because it's updated, the data has to move as well, right? So RexRay is an open source project that does that, and it has plugins for various online storage engines. And so we're going to deploy a stack file. And that stack file is going to do the job, because this is a common question that people have, is how do I do RexRay? How do I run arbitrary commands on my Docker Swarm nodes in a way that I don't have to SSH in each one of them? And the answer is Swarm exec is one of the ways to do it. Swarm exec is a tool from the Docker team. You can just see here, this is actually a stack file that you would, it's a compose file, right, that you put into a Docker Swarm. And it's running, basically it's telling each node to run a command once, and that command is a Docker plugin install. And there's lots of plugins. There's networking plugins, there's logging plugins, there's auth plugins for Docker. And this is a way for me to do this on every node with one command. And then the benefit of that is if I add any additional nodes in the future, because we're doing this thing called global mode, it will automatically run this command on those nodes as well. So it allows me to scale up and scale down nodes and not have to worry about my storage drivers. This thing takes care of it for me. And you can run anything you want in here, something that you would run on a set of servers in your swarm, right? Let's see if we're done. All right, let's try this again. So by the way, Docker machine, I made an alias. DM is Docker. I don't want to have to type out Docker machine every single command. So you can imagine I'm typing out the docker-machine command line. All right, so we have 3 running. And then we need to actually do that shell script I just talked about for enabling metrics. So we're going to basically replace that JSON file on all 3 servers. Now they have the metrics endpoint. And then we need to create our swarm. Doesn't really matter which node, because we're going to make all 3 managers. 3 is the minimum. 5 is probably the most managers you ever need in a swarm. If you have more questions about that architecture, my previous talk from last year at DockerCon is on the internet and talks all about those details of how you design that swarm. We just won't be able to cover it today. So I'm going to take this token and Docker machine, SSH, DVC1. So this is how I can actually use Docker machine to run SSH commands arbitrarily on different nodes. So I'm just going to, instead of batch scripting this out, because my argument here is that as long as this is reproducible, if you're a solo admin, not everything has to be scripted, right? As long as it's something that I'm doing on occasion, but as long as it's reproducible, I can do it over and over again. I don't necessarily have to do that in a shell script. So I'm doing this on all 3 nodes. So now I'm going to have that 3-node swarm, and it's going to have the metrics enabled. And then we're going to deploy our first stack. And that first stack, remember, is that 2 was actually where I created it. Yeah. Thank you. Keep me sharp. So I actually, up to top, I ran the create swarm shell script, which ran this command that essentially assigns the right Ethernet NIC and gives me back, it spits out that code that I need for the other 2 nodes. But thank you. So RexRay. So we're just going to do a Docker stack deploy to do that, right? And Docker stack, oh, well, first I need to actually connect to my swarm. And Docker machine helps you with that too. So I'm going to do Docker machine, Docker machine 1. So that will basically give the right environment variables to my local Docker CLI. So now that I'm talking over TLS to my swarm, and I can control it remotely without having to SSH in, because that's all my files are locally. I don't want to have to copy files into swarm servers and deal with it there. So now if I do a Docker node ls, I should see all 3 nodes in my swarm. Yay. I have 1 leader that's reachable, and the other 2 that are reachable, and 1 that's actually the elected leader. And we can now do a Docker stack deploy. We're going to do RexRay. We're just going to call it RexRay. And again, in the background, this is actually going to install the plugin driver for DigitalOcean storage so that any future apps I run on this, they will all get their own persistent storage off servers. That means if the nodes crash or the containers crash, it's just going to bring those MySQL databases right back up, connect it to the volumes in DigitalOcean's block storage, and away we go, right? Over on the right here in this little tiny window, what I'm actually going to do at the same, oops, I'm going to run this, instead of running like a visualizer or something that's going to show you, over on the right, what we're going to see, yeah, you can do it. There you go. It's going to start building out our stacks and our services. So you'll start seeing as we add more stacks in the right there, that'll be our equivalent of a visualization, all right, as we build this out. OK, so now we have our storage. Let's deal with our reverse proxy. It's a common problem, and traffic's a great solution. And all we really need to do is I'm going to create an overlay network, and then I'm going to apply a new stack to it that's going to run a reverse proxy container. And then we'll explain it while it's doing its thing. So Docker network create. Now, the reason I'm manually creating this network is because the proxy network is kind of special in this case. I'm going to connect anything that's web-based that I want to have outside access, client access to my swarm. I'm going to put them all on this network, and then I'm going to assign labels to them that then traffic will pick up from the Swarm API and then automatically reconfigure itself to manage those endpoints and receive traffic for them. And it's going to use layer 7 HTTP headers to figure out where the traffic needs to go. Okay? So now that we have that network created, let's do another Docker stack deploy. And this time, we're just going to do proxy. And so let's go take a look at that file real quick. So inside here is a traffic instance container. And I am setting, you can see here, I've actually got a couple of volumes because I'm storing the configuration for it in a JSON file. And then I'm going to give it a whole bunch of options for it to start up. And that's going to tell it what endpoints I want it to listen on, what ports, and we're actually setting up Let's Encrypt. A really great feature out of the box with traffic is that it will automatically go get your certificates from Let's Encrypt for you. And so in the end, what this actually does for us is that any new service I deploy, any new stack of my web apps, as long as I give them labels, with the proper labeling for traffic, it will pick them up, go grab their certificate, bring it back, store it, and then answer up on SSL for that domain as long as I've properly done my Let's Encrypt work, right? So it actually works really well. And you'll see on the right, we now have our second service up there. The traffic says 1-to-1, which means it's ready to go. We've only got one container of it, thinking small, a couple of servers, no big deal. Let's go on to our next stack. So I could actually pull up this URL, and you can see the traffic dashboard. And I don't have any endpoints yet because we haven't deployed any apps. But this is another feature out of the box with traffic, is that it gets a nice web GUI for seeing what's configured. So now I'm going to do my ops stuff, right? I've got my sort of utility plumbing in there. I'm going to do the ops stuff. In this case, I'm going to use 3 different unrelated projects that all just happen to run great on Swarm. ELK for centralized logging. That's the Elasticsearch bundle. Portainer is my web GUI that's going to basically manage my Swarm and my Docker engines from a web interface. Give me some options, whether if I don't want to have to go to the shell, I can always do it from the GUI, or I can switch back and forth. And then I'm also going to use Prometheus for logging. And each one of these, if you'll actually look in the repos later, are actually projects from the community that they create their own compose files of multiple tools that all work well together. And you can take the compose files with very little change. You can turn them into a stack file. Usually the only thing you're changing is ports and volumes and maybe a couple of environment variables. And now you can reuse that project that maybe was never intended for a Swarm, that was just maybe for Docker Compose locally. You can use that in your Swarm. So that's what I did. I actually used Swarm Prom, which is a project on GitHub. And I have all the credits and everything from all the awesome team members that are taking care of those projects are in there. And let's do this. Let's get back there. And the first one we'll do is Prometheus. Nope. All right. So in the case of Prometheus, it's actually a little complicated because Prometheus has lots of stuff to it. But I didn't have to do most of this work, right? The community has been vetting a project, and I just validated that everything was working correctly. It actually comes with config files built out of the box that are sort of templates for me to work with. I have multiple services here that all run. This all works in Compose. I just changed a few of the things to work in a stack file. I did things like what you should always do in production. If you're going to use logging in Docker and you're not going to ship your logs somewhere else, you need to limit them. Otherwise, they'll fill up your disks. So do something like that. And then you can see in some of these, let's find out. This is what I have to put in. I don't know if you can read that or not. Let's see if I can make that bigger. Oops. I have 3 lines there, basically. The port that the container is going to listen on, the network that it needs to be on, and then the host name that I want it to respond to. And that's all that traffic requires in order to see that stuff. So then we do ELK, which is our logging stack. 3 different containers that work together to centralize logs and store them for search and graphical interfaces. And then the last one is Portainer. And then we'll take a look. OK, so you can see on the right how they're filling out, right? Our stacks are deploying services. It's downloading the images in the background. It's opening up those ports to traffic. And we're going to do a few more, and then we'll take a look at the GUIs. All right, and now we're to our apps. So now I've done my ops stuff. We'll go check those out in a minute. But now I just have to deploy a few more stacks in the same manner for my apps. And this can happen to infinity, right? As long as you have enough resources and you have enough nodes, you just keep growing these things. And each one of those tools is designed to handle whatever apps I throw on it, right? Obviously, as you scale your number of apps, you're going to have to scale your other infrastructure and increase resource limits and stuff like that. But to a certain extent, this is sort of to infinity, stack deploy, right? You can see that I have some resource limits. These are all actually coming out of the templates for a lot of these. If you go look at the ELK template, it's 3 different services from Elasticsearch. They properly set the Java memory options, which if you've never run Java in Docker, you know that you've got to do that. And opening up ports that they need to be listening on, and away we go. So let's deploy our app, right? We talked about the 3 different stack files for our app. Let's just deploy those real quick. The voting app. Everything's slower during a session. And then our blog, our Ghost blog. All right. And then lastly, just our static website. And you'll see on the right as they continue to fill out. Now, as soon as the menu's ready, that's the static website, I should be able to go to www.dogs versus cats. And there we go. OK, and now I can start clicking away. This is a silly little yay HTML. I know a little bit about the internet. And so you can start voting away, right? I can actually start something silly like, why don't we just DOS ourselves? Come on. Wow. This is rough. So I can use something like Apache Bench to throw a couple thousand votes at my voting because I want to, I want to see the vote, and we probably don't have the backends all the way up yet, so it's not going to run the queues yet. But we'll wait. We'll wait for that. We'll come back to that in a minute. Okay. So, all right, maintenance tasks. So maintenance tasks are like common things. There's actually a really great file in here that we won't have time to go through, but maintenance tasks are things in your swarm like cleaning up images, and it turns out stuff like that is not hard to do. Here's an example of me doing a simple bash one-liner to do a Docker image prune every day and then wait and basically sleep. I don't have to create some fancy job system in order to, Docker to a certain extent, Swarm kind of does that for you. It doesn't have all the advanced features of some job engine with retry and all that stuff that you might need. But, it's okay if this thing accidentally runs twice a day. It just simply cleans up images. It's not built out of the box with Swarm, but it's really easy to do. So I would deploy this, and I would be able to clean that up. Backups? Backups can simply be something that's in the stack files with the apps. So maybe in my Ghost app for my database, right, I have a normal MySQL container, but I can use a service and just call it DB backup, and then I'm changing the command on runtime to say, hey, don't run the MySQL server, just run the MySQL client, the MySQL dump command, dump it out to a volume, specify the volume in the file, and away it goes on that storage off a disk, right? So I don't need some fancy backup system necessarily. If you're doing cron stuff today, just do it in this manner. I mean, obviously, if you have something more advanced that you need, you do that. But this is effectively like a simplistic cron system. Day 2 operations are not going to be a part of this talk. It'll probably be a future talk. But essentially, what you're going to be doing is stack deploy to infinity, right? Every time you want to change one of these things, you're doing stack deploys. Micromanage your update configs and health checks. If you're going to do any updating, which is basically everything you're ever going to do, you have to have health checks. Every single one of your compose files must have health checks on anything you expect to stay up when you do a rolling update. There's no way for an orchestrator to know if your app is ready for connections without health checks. So even simple ones are better than nothing. And that will help you have zero downtime rolling updates. And update config is a part of that. Docker now has tons of options out of the box. Tune your limits and reservations. This is like 101 sort of resource management and ops, and I see so many production systems where they don't do that. So just go day 1, deploy it, and then learn what your limits and reservations need to be in test and dev, and then be conservative, give it more than it maybe needs, and then once you're in production, realize that you maybe tighten those down. Otherwise, you're going to have MySQL servers taking all the resources from your APIs. It's just going to happen, right? If you don't limit that thing down, your SQL databases are going to take everything, and your other stuff will not. So just do that. Security, on this you could do Docker Bench. All these resources again are links in the website. Docker Bench is to scan your servers and check for security features. You could use the Aqua Microscanner from Aqua Security that just came out a few weeks ago. It actually now has a Jenkins plugin as of today, I believe, that was announced. And then Sysdig Falco, you could try something like that for behavior scanning, like is anyone actually SSHing into my containers because they shouldn't? Should they, is someone reading files from the Etsy directory on my host because they shouldn't? So you can sort of do that sort of stuff. And then, and user namespaces. A lot of people don't even try user namespaces, but it's super easy to get started with it. Using the default profile from Docker, they have lots of documentation on it. Thanks to Phil Estes and the IBM people for putting that into Docker, because it's a great way to lock down your containers and run them as non-root. But it doesn't come out of the box that way. You just have to enable it in the daemon. It doesn't work in every case, but it works in a lot of cases with simple stuff. So I'm going to leave this list because we don't have time for it, but these are ways you could possibly grow your complexity over time, right, as you mature this infrastructure. So let's quickly, you forgot about the sound effects, didn't you? So let's quickly get to the next one real quick, because I want to just show you that it doesn't change that much when you get to EE. It just is more of the same. In fact, if you're an Amazonian team, and sticking with our sci-fi, and you're going to be on AWS, this is what we just had with CE. Now you're going to be on EE, and you're going to get all those features back, right? So out of the box, I'm not sure if you realize it, but Docker has removed support for the Docker for AWS and the Docker for Azure templates. Those are no longer a thing. In fact, if you want to deploy a new cluster, you can't anymore with these templates. If you have the templates, you can keep using them. They were just templates. But they're no longer a way to deploy because they're not that flexible. So I guess they were getting a lot of feedback that it just wasn't meeting a lot of everyone's needs. The new thing you need to look at now is a Docker certified infrastructure, which is basically Terraform, Ansible, and other things for how, and guidance, lots and lots of guidance on how to build out your infrastructure on Docker EE. So this is not something that maybe one part-time person with 10 servers would need, right? Unless they're doing EE. If they're doing EE, this stuff is designed to deploy it automatically for you. So it comes with 3 different parts. You can dive into the documentation on the Docker Success website. Again, links are all in into the talk. And then basically the automation tools is what we would use. When you look at the network diagrams, it looks even more complicated, but really if you just dive in there, you realize it's the same design patterns. We're just using more of the same things. We've got load balancers in the front. We've got UCP managers, which are swarm managers. Obviously, we have things like DTR that are an advantage. And then you just have lots and lots of workers and lots of overlay networks. So it's just more of the same here. It's not completely different. The stack changes because the tools become more aligned with Docker's way of doing things. So the blue lines are basically replacing our third-party open source tools with the ones that come with EE. And then you're using something like Terraform and Ansible to do Terraform apply, and then you're editing some files, and then you're deploying the Ansible playbook. Terraform creates the infrastructure in AWS. Ansible actually installs Docker EE and all the features you need, like persistent storage drivers and all the agents on all the machines, and connects them all to the swarm, so on and so forth. So the advantages, obviously, are you get more flexible tools out of this for deployment. You have more SecOps out of the box. You have high availability of all ops tools, unlike the CE swarm, where we didn't necessarily have high availability built out of the box with everything. We'd have to do that manually. And then your tools are now team ready, which means everything allows you to you can give logins to people and then revoke them when they leave. You know, if you've ever tried Swarm CE, you know that it doesn't have that RBAC out of the box, so you have to do something like Portainer on top of it. And then if you want to give people CLI access with CE, they still get root, whereas with EE, you don't get that. You actually can control and limit, like we saw in the demo this morning. They stole my thunder on that. And then if you want to swap out to Kubernetes, you can totally do that on EE. It's simply just a redeploy of your stack files. So this is what it would look like. We would do the exact same commands, or just drag and drop them in the GUI, right, into the GUI of Docker EE. And the only things we would actually change are the storage drivers, and I'll just show you. Like, we changed the labels to be Docker's version of the labels for the load balancer, and then we would change the storage driver to be Docker's cloud store driver. And that's really it. I mean, these files work the same way in both completely different infrastructures, completely different clouds, different designs, right? So, Next steps on this design would be all things in, do all the things I just mentioned in Swarm CE. Do those on EE, right? Consider user namespaces and extra security tools. But then Docker provides documentation now on how to enable CloudWatch and Telegraph, which gives you, if you're an AWS person, right? If you're going all in on AWS, then you're using CloudWatch logs, you're using CloudWatch monitoring, and the CloudWatch monitoring needs to see your containers. That's what Telegraph can do. It can pull out those metrics, put them into CloudWatch for you so you can see the containers. Logging, like I said, CloudWatch logs. All this stuff is actually a part of that Docker certified infrastructure. So I recommend that you start reading into it. It's really early days. It is a 1.0 release, so not everything is perfect out of the box. There are at least a half a dozen things I had to kind of tweak in order to get the demo that I unfortunately don't have time to do, which is really just me showing you that EE is up and working, and then I click on something. Which we're not even going to do that, because that's boring. So to wrap, because I want to leave some time for questions. But the summary here is infrastructure as code is a real thing, and it's really achievable here. Making everything repeatable out of the box. Don't create special nodes. I see this so often is people designating a node for putting their compose files in and their shell scripts and all that stuff on nodes in swarms. Don't do that. Use the remote TLS like I just did to talk to your swarm remotely and leave that stuff off those servers so that any of them can be replaced at any time and they're not special. Grow as you go. Start small. Grow the complexity over time. Looking for compose files, right? Helm is a cool thing on the Kubernetes side, but we don't have sort of that equivalent place yet. Although there is a tool that's being launched today by, I can't remember the Docker team's name, but Gareth, thank you. Gareth is actually releasing a tool called Docker App. It's an open source tool for taking compose files, putting them in images, and using Docker Hub as a distribution method for compose files with templating built into it. So check that out. It was a session that's actually, I think, going on right now during mine. So check that out, the recording. It's really early days for it. But that's going to be a better way probably to manage your team's infrastructure with deploying apps that way. And then last bit, don't throw out the good in search of the perfect, because I see too many teams forsaking reasonable methods that are maybe not the end-all be-all just because they want the utopia. And the utopia is probably 10 times the work, right? So please try to avoid that. First, I'd like to thank the internet for all the tools we have today. Again, I really encourage you to take advantage of the open source that I showed you. Please support it. If you have anything, just do GitHub issues. Like if you're not a developer, just get into GitHub issues, answer other people's questions. All these projects are worked by volunteers, obviously. And that's the URL. Just go check that out for the links. And then we'll have time for questions. Just a couple of minutes. Oh, no? No questions? Okay.